Hi everyone, welcome to ITS workshop. Let us talk about one of the most important framework in core Java, that is collection framework. So whenever you are dealing with some very common data structures in your program, in your project, like list and set and map and queue, so you are dealing with a group of object and you are organizing, storing, retrieving those group of object in certain manner. So you don't need to write anything from scratch, you don't need to write those classes and methods from scratch. There are some interfaces, there are some classes available for you in collection framework. So basically the data structure solution for your programming. So that's what we get in collection framework. So the literal meaning of collection you can consider like sometimes also known as container is simply an object that groups multiple elements into a single unit. So like in this example we have multiple elements, those are letters. So if I create a group of these letters and put into one container, that is collection. So like letter object, and letter object can be considered in list or array list. So for example, list of letters. So list of these letters, you can say this is my collection of letters. It can be letter object, it can be user object, like whenever in your application you are supplying username and password, so from it passes from different layer, and basically we are dealing with object. So there is not one user always, there are multiple users and we are dealing with multiple users. So we are creating collection of those users. So we are dealing with a group of users, we are putting them into some collection, some list, some array list, some set, some map. So in different data structure we are putting object differently, and we have certain methods, certain properties for dealing with them. All those things are coming into collection framework. So collections are used to store, retrieve, manipulate and communicate aggregate data. So aggregate data, it means we have group of data or group of object. So we want to store those objects, we want to retrieve, we want to manipulate, and we want to perform some other stuff with those aggregate data. So that comes under collection framework. So why should I use collection framework? So one thing I have already told you, like you don't have to write everything from scratch. There are some classes and interfaces, like basically in 4 flavors: list, set, map and queue. So collection framework provides high performance, high quality implementation of useful data structures and algorithms. So definitely we are dealing with different data structure. You don't have to write from scratch, and still using collection framework interfaces and classes we are getting good performance and better quality implementation. So that's the one reason. And you when we say collection framework, then you need to be careful about these 3 things. First, the collection with a small c or lowercase c, the collection with capital C, and the collections capital C and ending with S. So you need to be careful at what time we are talking about which one. So when we say lower C collection, it means it is very general term and it is representing any of the data structure. When I say collection with capital C, it means I'm talking about interface. So the collection interface is in java.utility package, and from which set, list and queue are extending. So we don't have direct implementation of collection, but we'll see how those are implemented. When we say collections is a class. So it means we are talking about a class coming under object category. So that holds a pile of static utility methods for use with collections. So be careful at what time we are talking about which term: collection lowercase, general term, collection interface, and collections class. Next, this is the structure of collection framework, you can say. So we have collection interface. From collection interface there are three interfaces, those are extending to collection interface: set interface, list interface, and queue interface. And from set interface there is hash set and linked hash set, and another interface like sorted set and navigable set are extending set interface. Under list interface we have three things: array list, vector, and linked list. And linked list is something which is implementing list interface as well as queue interface. And there is something known as priority queue which is also implementing queue interface. So basically three main interfaces: set, list, and queue, and other classes and interfaces are coming to it. So next structure you can consider with map interface. So map interface has nothing to do with collection interface, but still it comes under collection framework, you can see. So from map interface, hash table class is there, hash map and linked hash map is there, and tree map, navigable map, sorted map interface, and navigable map interface are coming through this, and tree map is class. So all these interfaces are returned separately. And collections class is coming from object. So like arrays and collections class coming from object. So these are basically three structure. There are some other classes and interfaces, but these three structure you can consider the frequently used one, and so try to keep this in mind. First coming from collection interface, second map interface, and third collections class or arrays and collections coming from object. So there are collection, we can categorize our collection in four basic flavors: list, set, map, and queue. So what is the list? List is a general list of things, so classes that implement list. For example, a couple of salesmen are there in a company and they are going out to sell their product. So one salesman is taking the route number 1, other salesman is taking the route number 2, other salesman taking route number 3, and other salesman again taking route number 2. So there are bunch of salesmen, those are going out for selling their product, and it is very general scenario that duplicates are allowed in this. Obviously two salesmen can consider same route when they are going out for selling their product, like from company to some common bus stop, they can take that route. So if you are dealing with such data structure where your objects with which you are dealing is general list of things, like your mom asked you to go market and purchase such a certain item, so you are just creating list for that. So that sort of list, if you want to organize, you can consider list interface, and in the list duplicates are allowed. So just keep this in mind, that duplicates are allowed in the list. Then we have something known as sets. So sets are unique things. So unique things, it means duplicates are not allowed. So if we consider salesman's example again, salesman going out for selling their product, it is common scenario that we have seen two salesmen can take a common route when they are going out, but their area of selling will be different always. So in area 1, one salesman is selling his product in area 1. So one salesman won't like to interfere in the area of another salesman. So that's how they go out and they divide city into their respective area or respective territory. So one salesman won't interfere into the territory of another salesman. So that's how. So whenever you need any data structure where duplicates are not allowed, you don't want duplicates, then you can consider sets. Other thing is map. So maps are things with a unique ID. So like general key value pair. So like in salesman example, we have some key and associated product with that key. So there is one key 443 and there is one product skyhook which is associated with this key. So likewise, most of the time, like here in this example, product IDs are key. So IDs are generally key and the real object associated with that ID can be considered as value. So basically you are dealing with key value pair, like user ID and other user attributes associated with that ID, product ID and product associated with that ID. So that is map. Then we have queues. So queues means things are arranged by the order in which they are to be processed. So generally when I say queue, then FIFO order comes in mind, first in, first out. But it is not necessary that queues are always in, first out. We may have priority queue, we may have LIFO queue. So we'll see how to implement these and which are the classes associated with these. So basically you can remember 4 types: list, set, map and queue. For list, duplicates are allowed. For set, duplicates are not allowed. Map are key value pairs, and queue in which we have certain order of processing. Then there are some terminologies associated with collection framework. So in next couple of videos we'll see collection framework in detail, we'll see each interface, we'll see each classes. So it's better to go through some common terminology like iteration. So iteration is nothing, just walking through the elements one after another, starting from the first element. So I am at the first element, like in array I am at 0th element and I want to iterate through 10 items. So I'll say item 0, item 1, item 2, item 3. I'm proceeding like this. It means I'm iterating through elements and starting from the first one. Then there is something known as ordered or unordered. So when a collection is ordered, it means you can iterate through the collection in a specific order, not random order. So like when we are iterating through the objects, some order is there, some rule is there. It's not like we are just randomly picking one object. So for example, hash table collection is not ordered, while an array list is ordered, and because array list we are maintaining index, so from index position array lists are ordered, and linked hash set are ordered by insertion. We'll see how these are ordered or unordered. Next is sorted. So a sorted collection means that the order in the collection is determined according to some rule or rules, so known as sort order also. So sometimes it is also known as natural order. So sorting is done based on the properties of the object. It has nothing to do with when particular item was inserted, how you are going to iterate it, how you are going to remove this. It has nothing to do with the processing, but it has something to do with the property of the object itself. So sort order including natural order is not the same as order by insertion, access or index. So it has nothing to do with order of insertion, access or indexing. For example, if we are talking about string objects, then the natural order is alphabetical. So from starting from letter A, B, C, like that we are proceeding. And when I say integer object, the order is numeric order. So it can be ascending or descending. And when we are talking about other objects, it means we have to give this logic of comparing with each other when one object will be considered as bigger from the other object. we'll be using comparable or comparator interfaces. So we'll see how to implement these interfaces for different objects. So that's it for today. That's it for this video. If you like this video, please click on like button. We'll be continuing with the collection framework and other Java projects in the coming videos. Please subscribe for more videos like this. Thank you.